Today we're going to talk about how to prove that a quadrilateral is a parallelogram. There are basically four ways to prove that a quadrilateral is a parallelogram. First, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So if you have a four-sided figure and the diagonals cut each other in half, which is what bisect means, then that shape is a parallelogram. If one pair of opposite sides of a quadrilateral is both congruent and parallel, then it's a parallelogram. So if you have a four-sided figure and one pair of sides is both parallel and congruent, then that shape is a parallelogram. If both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. So again, if you have a four-sided shape where opposite sides are congruent, then it's a parallelogram. Finally, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if you have a four-sided figure again, and opposite angles are congruent, both pairs, then you have a parallelogram. So our first set of examples, we are trying to find the values of these variables for each parallelogram. So they're telling us that we have parallelograms. All right? So opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary, which means they add up to 180. And the diagonals bisect each other. So we're looking for one of these four things to take place in these diagrams. So looking at this first example on the left, I noticed that angle Q and angle R are consecutive angles. So I know that these two angles, angle Q plus angle R, are going to add up to 180. So I'm going to take the expressions for those two angles and plug them in. So A plus 40 plus angle R, which is A, total 180. I'm going to go ahead and solve this using algebra. All right, I have like terms here, so that's 2A plus 40 equals 180. I'm going to move 40 over by subtracting it. Those cancel. 2A equals 180 minus 40 is 140. And then divide both sides by 2. And A would equal 70. So if I took 70, plugged it back in here, I know that angle's 70. And if I plug 70 in here, 70 plus 40 would be 110. Together, 110 and 70 give me 180, so that works. Next, we're looking at sides. Now, in a parallelogram, opposite sides are congruent. So I know PQ is congruent. PQ is congruent to SR. So I plug in their expressions. 3C minus 3 equals C plus 1. Solve for C. First thing I'm going to do is get the variables on one side. So I'm going to minus C from both sides. That gives me 2c minus 3 equals 1. Add 3 to both sides. Cancel those out. 2c drops down. And over here we have 1 plus 3, that's 4. Finally divide by 2. And c equals 2. Now I'm going to plug that 2 in for c. Either one should give us the same answer, so let's check. 2 plus 1 is 3. And plug it in over here. Plug in 2 here. 3 times 2 is 6. 6 minus 3 is also 3. So that works out. Next we have diagonals. Diagonals bisect each other inside of a parallelogram. Okay, so I know this diagonal LN is cut in half by the other diagonal. So I know 2y plus 7, 2y minus 7. Get my pen back here. 2y minus 7 is equal to its other part, y plus 2. I can go ahead and solve that for y. Move the y over. Gives me y minus 7 equals 2. Add 7 to both sides. All right, those cancel. Y equals 9. Okay, if I plug 9 back in here, 9 plus 2 is 11. Let's check to see if it works here. 2 times 9 is 18, minus 7 is also 11. We're going to work that same concept with this diagonal. That diagonal, PM, is cut in half by the other diagonal, okay? So I'm going to set those equal. 3x equals x plus 5. Solve for x. Subtract x from both sides. Those cancel. 3x minus x, 2x. Bring down that 5. Divide both sides by 2. X would equal 5 divided by 2. That's 2.5. Now I'm going to plug 2.5 in for x. So this would be 3 times 2.5. Okay, over here we have 2.5 plus 5. Both of these give you 7. Sorry, 7.5. Example 2. We're going to use our properties to see if the quadrilateral is a parallelogram. So we're going to flash back to that first slide. We're going to try to see if one of these 4 are present. All right, so right here we have one pair of opposite angles congruent. Okay. Over here we have alternate interior angles on both parts. Now, if both of these are congruent and both of those are congruent, then I could say that that whole angle is congruent to this whole angle. So this one's a yes. Both pairs of opposite angles are congruent. Coming over here to this one, we have 2 sides equal. Now these 2 sides are adjacent. These 2 sides are adjacent. Now when you have 2 pairs of adjacent sides congruent, that actually is a kite. Okay? So this is no. That's not a parallelogram. Coming over here we have a pair of parallel sides, and I notice that both of these sides are labeled X, which means that they're congruent. So this is a parallelogram because you have one pair of congruent and parallel sides. Last but not least, we have this diagram here. Now this may look like a rectangle, but we have to have proof that it's a parallelogram based on those four principles stated earlier. Now this diagonal here, it looks like it's cut in half, but it's not. Okay? This one tick mark is actually congruent to the other part of this diagonal. Now, if the one tick mark was over here, then I can say that these are probably going to be bisecting each other. So this is a no. Okay, so again, to summarize our lesson, to prove that quadrilaterals are parallelograms, the diagonals have to bisect each other. That's one way. You can have one pair of parallel sides and congruent sides. That would actually automatically make the other sides congruent and parallel as well. You can have two pairs of opposite sides congruent, or you can have two pairs of opposite angles congruent.